Hello everyone, this is Sudip Chanda. I'm working in power transformer industry for more than 12 years as an electrical design engineer. Today I'm going to start my YouTube channel where I will be sharing with you all the important topics related to power transformer. Also, in my channel, I'm not going to share any proprietary knowledge which I gained working with my previous company and my current company. The things which I'm going to share is completely based on the experience I got in last 12 years while doing the transformer design. I hope you will like my videos. So friends, today's topic is connections, where I'm going to tell you about how to make connections for YD1, YD11, DY1, DY11. In order to understand this concept, first of all, we need to see what is the actual vector diagrams look like for all of these. For an example, I'm going to take YD1 and will tell you that exactly how we are able to make the physical connection in the transformer. So for YD1, since Y is generally the high voltage side and delta, the second line, represents the secondary side or the low voltage side. So now here what the reference value we are taking is the high voltage side, which is Y connection. So if you see the diagram, vector diagram I have made is A, B, C as a star connected 120 degree apart from each other. Now I'm going to make the delta winding for connection number 1. So first of all, what this 111 represents. If you see, this 111 is basically nothing but it represents what is the phase angle between the high voltage and the low voltage side. So in order to understand it better in simple terms, if you imagine a clock has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In this clock, this Y is the reference point, which we always say is at 12. This high voltage will be always at 12. So let's say this A with this reference is at 12. So this delta 1 represents that secondary should be on number 1 position. So the delta, if that is the reference point A here, so the secondary A point should go here. So if you make the lines meeting the center point, you will see there is a 30-degree angle between the 2 points, which says that delta is lagging the star in YD1. Now we will see how this lagging and leading works. So since this is the high voltage winding side, which is a star, and delta has to be at 1, so I'm making this delta, it is at 1, so this will be A, this will be small b, and this will be small c. So if you see this reference point A, small a, this is 30-degree apart. So now, generally, the phase rotation is always anti-clockwise. So if this is the vector diagram you will get, that is YD1, this is Y, D is at 1 position, A is at 12, 1 position. So this D, the secondary, will always be from the reference point of high voltage side. So now what we will do is we will make this anti-clockwise rotation here and try to see how lagging and leading is working. In this case, the phase rotation is actually A, then C, then B. You can also have a phase rotation of A, B, C based on the rotation requirement. Generally, as per IEEE, we have the rotation which is anti-clockwise. So in this case, if you take a dot here, dot mark here, and now try to rotate this phasor Assume you are trying to rotate this phasor towards this dot because it is anti-clockwise. The first point which is going to pass through this dot is this A. So first point which will pass through is capital A of this phasor. The second point which will pass is small a. In this case, A is passing first, capital A is passing first through this dot and then followed by small a. So we can say that capital A is leading small a, or small a is lagging then capital A. So whenever there is a requirement of having secondary lags primary by 30 degrees, it means the secondary, in this case is D, that is delta winding, is lagging the primary winding by 30 degree. Or if the requirement is primary is leading secondary by 30 degree, that also means this connection is going to be YD1, because in this case the primary is leading the secondary. Similarly, we are going to make the vector diagram for YD11. So here you see the high voltage side is a star winding. So we will make a star winding like this. This is capital A, this is capital B, capital C with rotation of anti-clockwise. Now delta should be at 11. So this capital A high voltage side is a reference point, will always be at number 12 of the clock. And this 11 is here of the clock. So now if in order to make a delta, the point of the secondary delta will start from here and it will come parallel to this line. Then this will come parallel to this line. This will come parallel to this line. And this will be A, small a. This will be small b, small c. If you make a line like this and meet at the center, you will see that this delta is 30 degree apart from the star. Now, if you put a dot over here, you will find that the delta is passing through this dot first and then followed by the star. So in this case, we can say that delta is leading star, or star is lagging delta. Since star is your primary, delta is your secondary, you can say secondary is leading primary, or primary is lagging secondary. Now we will see the case which is dy1. In order to make dy1, same case, the reference point is now delta. So we will make a delta like this, which is capital A here, capital B, capital C. Rotation is anti-clockwise. And now the y. In order to make the y, first of all, we have to make a reference point. So let's make a reference point and meet at the center of the delta. So this A is at number 12 of the clock and y is at position number 1. So what we have to make is the y, which will look like something like this. Now you will see that the star and delta having a phasor difference of 30 degree between the two. So this will be small a, this will be small b, this will be small c. So in this case, we are saying that delta, again, delta is leading the star because it's anti-clockwise. But now, since the reference point delta is the primary winding, so we say here that the primary leads secondary, or secondary lags primary. Similarly, for case of dy11, again we are going to make a delta. This is capital A, capital B, capital C, anti-clockwise rotation. Let's make this come at the center, this line comes at the center, and then this Y is at 11 position. So A is at 12 position, we know, because this is the primary winding. Now Y should be at 11 position, which is here. So now we will make the Y parallel to this line, this will go parallel to this line, and this will go parallel to this line. So this will be small a, this will be small b, this will be small c. Taking your dot point here, you see now the star is star is leading delta, or delta is lagging star. Since B is the primary winding, so secondary is leading primary or primary is lagging secondary. Phase angle is 30 degrees between the two. So now we are going to see how we make physical connection in order to achieve YD1, YD11, DY1, DY11. So if you see the Y here, YD1, Y is the high voltage side, D delta is the low voltage side. So let's make YD1 connection in a practical transformer. As you know, the windings we can represent like this, and let's say this is a high voltage winding. We will name the winding as A, B, C, or you can name the winding as 1, 2, 3. This is the star winding, so it is going to make a star connection here, and there will be a neutral point coming over here. Now you have to remember always that the point where I have written A, B, C, this is the line end of the transformer. This is the line end of the transformer. It means this is the point which is going to go to the high voltage bushing. This will go to high voltage bushing. This will go to high voltage bushing. This will go to high voltage bushing of C phase. This will go to neutral bushing of the transformer. Similarly, the delta winding will also be like this. So these are the 3 coils. So this one completely makes phase 1, this one will make phase 2, this one will make phase 3, or A phase, B phase, C phase. Again, remember that this is the line point. This is the end which will go to the low voltage bushing. This is the point which will go to the low voltage bushing. This is the point which will go to low voltage bushing. So when you make a transformer, the transformer actually looks like a 3-limb transformer will look like this. So you have a low voltage winding, over this winding you will have a high voltage winding. So the high voltage winding, this will be the line end, let's say 1. This will be the high voltage winding, let's say 2. This is the high voltage winding, let's say 3. And then the neutral will come out and it will make a HO, or a neutral for the high voltage winding. Similarly, you will have small a, the low voltage winding, coming out of the same limb for A phase, small b for the B phase, small c for the C phase, and will make a delta winding. So here we are trying to make the physical connection so that we can achieve YD1. So this is Y connection. Now similarly, I will make the 3 coils of the low voltage winding. So this is small a, this is small b, this is small c. Now the question is how to join this LV in order to make DY1. So here is a small trick to make it, and it is very much successful. So now in order to make YD1, what we will do is, as I described earlier, let's make a clock. In this clock, this is number 12, this is number 1. So your high voltage is here, and your delta is actually here. So we will look at only one point, because all the other points are going to be the same. All the other phases are going to be the same. So let's concentrate on only one phase. So you will actually have like this. but the delta is here at 1. So now the reference point is y, which is at 12, so you need not to worry about that. Now we have to make D1 connection. So write this as it is, A, B, C. And now if you see the delta is at 1 point, point number 1, or clock point number 1. So you keep this like this, and you see this is at 1. So the angle what you are getting is on the right hand side 30 degrees. So you put exactly the same starting from the line end. You put a line towards from 1, considering this as position number 1, towards the center. You will have to drag the line towards your left hand side. Then on the B, you will have to drag the line towards the left hand side. For the A, you have to drag the line towards the left hand side. It means in order to make YD1, you have to connect C to bottom of B coil, and the top of B coil to bottom of A coil, and top of A coil, there is no coil over here, so it will go to bottom of C coil. So once you make this, with reference to high voltage star winding, this delta is at position number 1, which is lagging the high voltage. Now similarly, let's see how to make YD11. Now D is at 11th position. So again, with respect to clock, this is the Y, so Y is here, and D is at 11th position, is 11 here. So A is here, capital A is here. So if you see, if you try to take this A and move towards the center of the clock, it is towards your right hand side. So we'll start from here, assuming this is 11 point, and we'll drag this towards the right hand side. So it will join B. Now similarly, start for B, it will be C. Similarly for C, you will drag this towards the right hand side, but there is no coil here, so automatically it will go to the bottom of A. This is how you're going to make YD11. Now there is a very small trick for making DY1 and DY11. It is same concept like YD1 and YD11. So now what we are going to do is, first of all, here we see this is delta. So delta is the reference point. So delta will be at 12 position and Y is at 1 position. So this is capital A, this is small a. So this is at position number 1. So now, in order to make the connection, we have to make 3 coils again. This is primary coil. This is secondary coil or low voltage. This is high voltage, this is low voltage. This is capital A, this is capital B, this is capital C. This is a small a, this is a small b, this is small c. Now, since this is a star winding, it is pretty much easy. You can just make a star like that and take this to make a neutral. And these are the lines. So see, you cannot do anything on the star winding. You have to short in order to make it a star. But delta, you can make different connections. So now, with delta, how we are going to achieve dy1? So if you see, this is the reference point, capital A. Now we have to rotate this vector diagram in such a way that we get star as a reference point. Although, as I said earlier, your reference point is always going to be the high voltage winding. But in this case, since high voltage winding is going to be the delta winding, so in order to make the physical connection, we have to rotate this vector and we have to consider small a as a reference point. So now if I move this, if I rotate this, I'm going to get phasor or the vector diagram like this. This will be small a and this will be your delta. This is capital A. So now again, this is still at 12, this is still at 1. But if you take this as a reference point, you will see this delta actually is at 11th position, considering A is at 12th position. So if you take this and go towards the center of the clock, you will see this point is going towards the right hand side. So if you take this point here and drag the line, you will have to drag towards the right hand side and go to point number B. Similarly, B, take this point go to C. We are dragging towards the right hand side. Similarly, C, we are dragging towards the right hand side. So it will go to bottom of A. This will give you dy1. Now we will see how to make dy11. So now in order to make this, you see delta is at 12, y is at 11 position. So y is here. So this is a small a, this is capital A. This is at position number 11. So now similarly, the way we did dy1, we are going to do for dy11, where we are going to rotate this vector so that the reference point will become star now. So this will be A, so delta will become something like this, capital A. If you see, the A is on the right hand side, capital A is on the right hand side, and if you drag this line towards the center of the clock, it will be towards the left hand side, starting from the line end. So starting from the line end, you have to drag this towards the left hand side, you have to drag this towards the left hand side, you have to drag this towards the left hand side, and then this A will automatically go and close the loop here. So this is how you're going to make dy11 connection. So friends, I believe I have chosen a small topic regarding the connections of yd1, yd11, dy1, dy11, and I'm certain that this is going to help a lot of people who have this doubt regarding the connections. I would like to request to comment on my YouTube channel what topic you would like to know, and I will try to make the videos and upload and share with you guys. Thank you for watching my channel.